Hello ladies and gentlemen, welcome to section 6.6. It's dealing with zero and negative exponents. We've already talked about zero and negative exponents a little bit with our graphing activity that we finished. But here is what we need to know for about zero and negative exponents. So make sure you are getting this information written down and learned there, and getting it committed to memory and so forth. When we talk about zero exponents, anything raised to the zero power is 1. And if we have a negative exponent, we think about, the analogy I like to use is it's a negative exponent, means it's not happy where it's at, so we need to move the exponent to a different spot. So if it's it's in the numerator, we move it to the denominator. If it's in the denominator, we move it up to the numerator. So we're going to get going here with a couple different examples. The first one we're going to start off with is zero exponents. We're talking about 3 to the 0 power. And so the main misconception we have, anything raised to the 0 power is going to give us 1. The reason why that's hard to kind of understand from time to time is because of the fact that when we multiply by 0 we get 0, and now we got to kind of change our thinking a little bit, and we end up with an answer of 1 there. The same thing applies when we have a variable raised to the 0 power. It's going to give us not just x, it's going to give us 1. Okay. These next two examples here are kind of confusing from time to time as well. We have 4x raised to the 0 power, so 4x to the 0. What that is saying is, remember back to what we were talking about with the power property. 4 is raised to the first power, so it's going to stay. X is raised to the 0 power. So we just talked about x to the 0 power is going to change this to 1, and it ends up being essentially 4 times 1, which gives us an answer of 4. So our final answer here is 4, because this 0 exponent is attached just to the x, not to the 4. Okay, and if we take a look at this next example, we have 3x squared, and that whole thing's raised to the 0 power. Now remember, how we're going to attack this one is, this is 3 to the first and x squared. And if we remember, we multiply our exponents. So that's going to give us 3 to the 0 power. We multiply our exponents again, we get x to the 0 power. And funny thing is these two examples were both up in our previous examples. 3 to the 0 is going to give us 1. X to the 0 is going to give us 1. So our final answer is in fact going to be 1. Okay. Now if there was something on the outside of those parentheses as well, then that would change your answer. But in this case, this is how we're going to work through those problems, and we end up with 1. Okay. So that's 0 exponents. So let's take a look at negative exponents now. All right, negative exponents, we're going to start with x to the negative 3rd power. So this is an x to the negative 3. This is in the numerator. So basically what this means is this negative exponent doesn't like where it's at. So we're going to draw a 1 up in the numerator now, because we have just a placeholder there. And we move the whole x to the 3rd power. When we move it from top to bottom, we make it happy, so it becomes positive again. Alright, so x to the negative 3 becomes x to 1 over x to the 3rd. The next example here makes it a little bit more complicated. We get x to the negative 5th, y to the 9th. Okay, so now the only thing that is unhappy is this x term. Okay, so the y term is going to stay put. It doesn't need to move. It's completely content with where it's at. But the x to the 5th is going to go below, and we end up with a final answer of y to the 9th over x to the 5th. Okay. Our next example here has 4x to the negative 2, y to the negative 8. Right? And this is very similar to what we were talking about with 0 exponents. The negative 2 exponent is attached to the x. The negative 8 exponent is attached to the y. The 4 has no negative exponent, therefore it's going to stay on top. Well, what moves is the x to the negative 2, it moves down to the bottom and becomes x squared. The y to the negative 8 comes down to the bottom and becomes y to the 8th. Okay, and then this becomes our final answer. All right, the last example here we've got is 5x to the negative 2y over z to the negative 6th. So, the thing I like to do is I like to circle my negative exponents so I know what I'm going to be changing. So I'm going to change those two things. So that means the 5 and the y are staying put. The x to the negative 2 is not liking where it's at, so it goes down to the bottom. It becomes x squared. The z to the negative 6th does not like being on bottom, so it becomes on top and becomes a positive 6. So we have z to the 6th on top. So our final answer is 5y z to the 6th over x squared. Okay, so we're moving different things around here and there to get ourselves away from negative exponents. Okay, so the last example here is a challenge problem that I'm going to give you guys. We've got 3x to the third over 5x. All of that's raised to the negative third power. The one hint I'm going to give you is I'm going to say break this down. We're going to have 3 and x to the third. That's on top. On bottom, 5 and x. Remember our power rule. This is 3 to the first, 5 to the first, x to the first. We multiply it by negative 3. Okay, so we have all of this going on right now. And what that's going to give us is that's going to give us 3 to the negative third x to the negative 9th, and that's over 5 to the negative third x to the negative third. So I'm going to stop here, and I want you guys to try and go from here. Couple hints. I would flip what we need to flip first, then simplify exponents, then divide where needed. Okay, and that includes the exponents as well. Okay, so I got you started here on kind of how this is going to look. I want you to try and finish this out. We're going to talk about it in class. This is a good way to try and test our skills and so forth there. All right, so that's zero and negative exponents. If you got questions, make sure you let me know in class. Have a good day.